Let's look at a few percentage change examples. First question is, what number is 30% more than 200? 30% more is 130% off. So we are looking for a number which is 1.3 times 200, which is 260. Or alternately, you can say 30% of 200 is 60 and add that 60 back to the 200 and you'll get 260. What number is 60% less than 450? 60% less is 40% off. So you're looking for 0.4 into 450. That'd be 45 into 4, 90, 180. 180. What number is 1200% more than 60? 1200% more is 1300 percentage off, which is nothing but 13 times off. So you're looking for 13 times 60, which is 780. Now let's look at these. 640 is what percentage less than 800? 640 by 800 would give you 0.8, which means 80% off. 640 is 80% off 800, therefore it is 20% less. The answer is 20%. 405 is what percentage more than 300? 405 by 300, when you do this, you will get, how much will you get? 1.35? Yes. That means 135% off or 35% more. You'll get 35% more. 1400 is what percentage more than 200? 1400 by 200 will give you 7. 7 means 700% off or 600% more. Next three. 560 is 40% more than what number? 560 is 1.4 times what number? The answer is 560 divided by 1.4, which is 400. 560 is 20% less than what number? 560 is 0.8 times what number? The number is 560 by 0.8, which will become 700. 2500 is 400% more than. 400% more than means 500% off, or it means 5 times. 2500 is 5 times of what number? The answer is 500. Those are basically one example each from every potential pattern of percentage change. And if you want a universal formula for this, your final value is 1 plus p% times your initial value. That is it. Now let's see how to use that as well. When you get 20%, you immediately convert the 20% as 20 by 100 and make it a 0.2. Don't write 1 plus 20 inside the bracket. It is 1 plus 0.2. And the convention is basically increase is positive and decrease is negative. So if you have 20% more, so the first question was 30% more than 200, it is basically 1 plus 0.3 into 200. Done. Now if you look at something else like the second one, 60% less than 450, because it's a percentage decrease, it becomes a minus 0.6. 60% less than 450, and you find the answer. Now if you look at something else like the seventh example, let's say seventh example says 560 is 40% more. The final value is given is 40% more. Because it's more, it's a plus inside the bracket and the variable is here. So this formula is pretty much universal to all percentage changes. You can just use this one if you're confused about what to quickly do in terms of a scaling factor, whether it's initial value or a final value. Just use the formula, it works for any percentage change. But it's not necessary to by heart this formula. Let's look at this example in more detail. Many of you might be wondering why I chose to divide and get the 135% first. Because we have learned something else in school, which is there are change a percentage change, which was the unknown here, a percentage change can always be calculated as change by original into 100%. Now, don't say change by original into 100, that changes the value, but 100% is just 1. We just add it so that we can finally get a convenient 100 as the denominator. That is all it is. Essentially, we are calculating change is a fraction of the original. Don't lose sight of this. Anyways, we have learned this in school. So you might be wondering, yes, you can just, what is the change? 300 became 405. That was an increase of 105, and the original was 300, and we use this to convert into a percentage. We cut this and we cut this, we'll get 35%. Why can't we do this? You can, obviously you can, no problem, and it might be actually more beneficial in certain situations, as in this one, because you might have noticed that I struggled a bit to do 405 by 300. Anyways, I just want to demonstrate that they are the same thing. There is no difference, because the formula that I gave you just a couple of minutes ago was that the final value is 1 plus percentage change into the initial value, right? Just make p percent the subject here, and you will notice that 1 plus p percent is f by I, and p percent is then f by I minus 1. My approach is to simply take the ratio and subtract 1, and the traditional formula that we used back in school is nothing but a distribution of this. Make I the common denominator, and you will notice it's f minus I by I, which is change by original, nothing else. So there really isn't anything different about these two approaches. It's just that you are distributing the denominator to get ratio minus 1. It's the same thing.